Okay, so this lesson is pretty basic. Students definitely learn this in kindergarten, and so they should be really, really successful. But um, then what that means is you really have an opportunity to extend. And so rather than just focusing on, like, okay, when I add zero, it means nothing, and so I still get the same answer, using that to really practice writing balanced equations and saying, okay, why is this still balanced, still true, still equal? And then using it to, yeah, just kind of explore and play, right? Like, can I scramble it around the wrong way and write it like that? You're really having those conversations and giving them a chance to explain all of that. So you'll review the big goal in math class. And today we're going to work at our desks, then come back to the carpet to share. And this one looks really familiar. It's like the day that we did the commutative property. You basically are saying, like, and that's just for you to know, teachers, right? You're just going to say, this was written. Do you agree? Circle yes or no. And I think what's going to be super interesting here, right, is really paying attention to which students decided to model this and which students just saw it and knew, right? Because ultimately our goal really is for them to solve it and know, but it would be great to use the cubes to kind of prove it and then explain that. So when we learn from our friends and you're setting up this as like the listening task while we're on the carpet, right? I assume you'll have someone share who really did use cubes, right? And I assume you'll have someone share who just saw it and kind of knew, and also have someone share it who was wrong, right? And not that it's like CGI in the sense that you'll hear all three people share and then talk, but like have the wrong friend talk, right? And then like let the group discuss. Have the next friend talk. The ones who use single cubes, let them discuss. And then ultimately the person who did it just with mental math, right? These questions that I have here, they are not meant for you to just like read rotely. You could use them for a check on understanding at the end, but hopefully these came up, right, when you had this discussion, right? And so this is just a check even for you. Like, did I talk about what happens when you add zero to a number, right? Kids should say very clearly, all of them, this is a great turn and talk, right, that the number doesn't change. You still get the same answer, right? The value stays the same is another way to say that. And why does that make sense? Because zero is nothing. It's not even really a part. And this is one way that they've summed it up, right? In this curriculum is to say, okay, so we've been talking about putting parts of a number together. Zero isn't even really a part, even the goal is the same place in a number sentence, right? Like really when we write 5 plus 0 equals 5, we're really just saying 5 equals 5. Because 0 is nothing. It's not even a part, right? Even though it goes in that part spot of our number sentence. That's what this means. And that's what we're trying to really understand. Do you see what I'm saying? Then just like, okay, how do I do 5 plus 0 equals 0? 5. And when I think about like the misconception, what's going to be interesting is kids can get the right answer and still not really get it, right? Like a bunch of kids can spend time trying to add these and filling it in, but still not understand that this is what they're really writing. This does come up, and it's really to help you check, did I get to the equation part, right? Because we're not just having conversations on the carpet, like, and vaguely, like, thinking about zero. We're trying to get here. And then it's IP time. They do get into super big numbers, right? And on this IP, and it's worth you thinking about, like, really talking this through, right? This isn't hard. They shouldn't be intimidated by it, and that's going to be kind of awesome.